If you remember, that day I mentioned very well and I explained. So pharmacodynamics is related to drugs. That means what drugs do to the body, and pharmacokinetics is totally opposite, like vice versa. So in case of pharmacokinetics, what body do to the drugs. Okay, so we will see today. Pharmacokinetics is the quantitative study of drug. Am I audible? You please mention once. Am I audible or not? Comment down below. So pharmacokinetics is the quantitative study of drug movement in and through and out of the body. That means when the drug is going inside the body, when the drug is moving inside the body, that is distribution of drug inside the body, and again out of the body. That means when the drug is going out of the body, that is excretion. All these three ultimately what body do to the drug, how body is taking, how body is absorbing, how body is distributing, and again how body is excreting out the drug. All these things comes under pharmacokinetics. So study of all these things is called pharmacokinetics. Okay, now we will see the intensity of response is related to the concentration of the drug at the site of action. So concentration of drug at the site of action is very important, which in turn is dependent on its pharmacokinetic properties. Now, pharmacokinetic concentration therefore determine the route of administration. So pharmacokinetic consideration is very important for route of administration, dose of drug, and latency of onset. So how fast you want the action of the drug, that is onset of action, and time of peak action and duration of action, and frequency of administration of a drug. That means in one day how many times or what are the number of doses you have to take in one day, that is frequency of the drugs. Okay, so all these things are totally related to pharmacokinetics. So you have to remember pharmacokinetic consideration, what it considers. The consideration therefore they determine the route of administration, dose, latency of onset, time of peak of action, and duration of action, that is onset of action, and frequency of administration of a drug. Okay, all pharmacokinetic processes involves transport of drug across the biological membrane. That is very important. Transport of drug across the biological membrane means, what does it mean? That day if you remember I explained, whenever you will take a drug throughout or after the administration of drug throughout the mouth, that is oral, what will happen? It will go into the stomach. After going into the stomach, what will happen? It will be absorbed into the circulatory system from the stomach through the membrane. So when the drug or when the percent, that is for bioavailability of the drug, absorption is very important. So from the stomach, when drug is being absorbed in the circulatory system, that biological membrane takes place or they plays a very important role. Why? Because if you remember, most of the drug will be non-polar, or you can say non-ionic. Most of the drug will be non-polar or non-ionic, which includes these most of the drug which are non-polar or non-ionic. These will be from oral route. Why? Because the cell membrane is polar or non-polar. Non-polar. Why non-polar? If you remember the lipid bilayer. So when you will see the cell membrane, you will see a cell membrane is made up of lipid bilayer. That also very important, and it is very well explained by sandwich theory. So these lipid bilayer, in these lipid are non-polar in nature. These lipid are also non-polar in nature, and in between them some polar nature will be there. Okay, some protein will be there, integrated protein and other uh, extra. Okay, so inside this some extra protein will be there which will create some channel. Through this channel polar drug will go inside, or polar drug will be passed through the biological membrane. But when the non-polar drug will pass through the biological membrane, it will directly pass through the membrane. Why? Because non-polar is soluble in non-polar. If you remember one universal line in chemistry, you will study, you would have studied that, that is like dissolves like. Like dissolves like is a universal sentence. What does it mean? It means if non-polar substances are there, they will be dissolved in non-polar medium, and polar substances will be dissolved in polar medium. So since the lipid bilayer in that the layer is non-polar in nature, that's why what will happen, all the drug will also be non-polar, so that their absorption will be more, so that their membrane permeability will be more. When membrane permeability will be more, absorption will be more, and when absorption will be more, the bioavailability will definitely be more. And when the bioavailability will be more, definitely ultimately it will show its pharmacological action very well. Okay, so that's why membrane transport is very important, or transport to the biological membrane, transport of drug across the biological membrane is very very important. We will study elaborately in the next topic. Today we will see the introduction of pharmacokinetics. Sorry, I forgot to mention one thing, that today everything is totally dark because of some issue, electrical problem, electric, or what it is called, current or problem. So you will not see my face today. Okay, next we'll see biological membrane. See, just few minutes ago I mentioned about the lipid bilayer, and you see here it is written biological membrane. This is a bilayer. He didn't mention that it is a lipid bilayer, but this is a bilayer. It's written here, it is a bilayer about 100 angstrom thickness, a phospholipid and a cholesterol molecule. See, lipid now mentioned. So in this, what it is constituted of phospholipid, and cholesterol molecule. Now, what is lipid and what is phospholipid? What is the difference between lipid and phospholipid? So when you will see a lipid see, this is a lipid. It is a lipid compound. Or you will see lipid are like this, like this, like this. These are lipid. When you will see one sugar is connected to that, this is called phospholipid. Okay, so phospholipid you will find first in that one sugar molecule will be added to the lipid, or sugar molecule will be bounded to that lipid, and that is called phospholipid. So the in the lipid bilayer you will see some phospholipid also, some cholesterol also, and the polar groups such as glyceryl phosphate also you will see there. Okay, so you have to remember all these things. Okay, now of these oriented at the two surface. See, that means that lipid bilayer are oriented at the two surface, and the nonpolar hydrocarbon chains are embedded in the matrix to form a continuous sheet. To form a continuous sheet. So ultimately, cell membrane is a continuous or discontinuous. So it is a continuous sheet. Okay, it's a continuous sheet which is made up of phospholipid, cholesterol, and other polar membrane or polar molecules such as glyceryl phosphate and ethanolamine choline or hydroxyl group of cholesterol. Okay, now this imparts the high electrical resistance and relative impermeability to the membrane. Extrinsic and intrinsic protein molecule are adsorbed on the lipid bilayer. So I also told you about the integrated protein. So integrated protein, I'll show you in diagram. See, this is a lipid layer. This is another lipid layer. In between these two lipid layer, you will see one integrated protein like this. Okay, and it will create a channel. Sorry, one integrated protein will be a what happened? Okay, no problem. See, you will see one integrated protein like this between the two lipid bilayer. This is one lipid bilayer. This is another lipid layer. Both will form lipid bilayer. This is integrated protein. Some protein will be present inside the bilayer that are called intrinsic protein, and some protein are present outside the bilayer. These are called extrinsic protein. So extrinsic and intrinsic protein molecule also adsorbed on the lipid bilayer. That means they are attached to the lipid bilayer, or they are present inside the lipid bilayer. Okay. Next, glycoproteins. That means some proteins will be there, along with that some sugar carbon will be bounded, they are called glycoprotein. Glyco means sugar, yes or no? So glycoprotein or glycolipid are formed on the surface by attachment to polymeric sugars. So this glycoprotein and glycolipid are very very important. And amino sugar or sialic acid. The specific lipid and protein composition of different membranes differ according to cell or the organelle type. So they differs cell by cell or type of cell by type of cell, that is called organelle type. In different organelle, the lipid and protein composition will be different, and in different cell also the lipid and protein composition will be different. Okay, next, the proteins are able to freely float through the membrane, associate, and that's why they leads to um, bilateral movement. They leads to bilateral membrane. So you have to remember the membrane associate a organize or vice versa. Okay, freely float through the membrane and associate a vice versa movement, that is bilateral movement, you will see. Okay, some of the intrinsic ones which extend through the full thickness of the membrane surrounds the fine aqueous pores. So what are these aqueous pores? These aqueous pores are also called aquaporins, and these aquaporins allows the water soluble substances through the membrane. These aquaporins allows the movement of water-soluble substances or polar substances or ionic substances through this aqueous membrane. Okay, and they also allows three types of movement. One is called uniport, one is called symport, and otherwise called antiport. In antiport, two membrane will be see, this is the antiport. In the case of antiport, what will happen? There will be movement of two substances. One will be going inside the cell, another substance will be going outside the cell. In the case of symport, both the substance will be going inside the cell. And in the case of uniport, you will see the movement of only one substance. You will see the movement of only one substance. These all three types of symport, uniport, and antiport are offered by whom? These are offered by aquaporins. Okay, they are called aqueous pores. Okay, next, paracellular spaces or channel also exist between certain epithelial and endothelial tissue or endothelial cell. Okay, so this is, see, these all are the lipids. These all are also lipids. So this is a cell membrane, and this is made up of lipid bilayer. This is one layer of lipid, this is another layer of lipid. In that lipid, see, these are the hydrophilic part, that means they are water soluble, and these are the hydrophobic part. Hydrophobic part will be present inside and hydrophilic part will be present outside. So what are these hydrophobic part? They are water insoluble. They are water insoluble lipids. And what are these hydrophilic part? They are water soluble. Hydrophilic are water soluble. And these hydrophilic will also allow the transport of ionic and water soluble and polar membrane or polar substances, whereas this non-ionic or hydrophobic part, this hydrophobic part will allow the transport of water insoluble or non-ionic substances. Okay, yes or no? See, this is the intrinsic protein. They are also called integrated protein. They are present throughout the cell membrane, outside and inside, across. So they are present throughout the cell membrane. And extrinsic protein is present only across the cell membrane, outside membrane. Okay, now see, we will understand this diagram. This is very very important. In the case of this diagram, okay, before understanding this diagram, we will see what is passive transport and what is active transport. So see, there are two different types of transport biological membranes allow. So see, number one is Other adsorb protein have enzymatic carrier. Okay, this is important. Enzymatic carriers and receptors or signal transduction properties, they will also help in the movement of substances across the membrane. Okay, now the most important thing is that biological membrane are highly dynamic in structure, and they allow only two types of movement or two types of transport. Number one is passive transport, number two is specialized transport. In the case of passive transport, what is diffusion? Diffusion is movement of substance across the membrane, movement of substance across the membrane from higher concentration to lower concentration. See, if you take two different solution, in one solution it is highly concentrated and in other solution it is weakly concentrated. In that case, what will happen? The highly concentrated solution, in that concentration will be more, and in weakly concentrated solution the concentration of the substances will be less and the concentration of liquids such as water and etc will be more. In that case, what will happen? From low concentration water will go to high concentration. And very simply, if I give you one real life example, then if you ever transported through train, then there are two bogies or two compartment. In that case, what will happen? Or two room. In one room so many people are there, in other room very less people are there. What will happen? From highly concentrated room people will go to low concentrated. Yes or no? So this is diffusion. So what it is called? Transport of substances across the membrane from higher concentration to lower concentration. So anything present in higher concentration, it will definitely try to go to lower concentration, and that is very natural. It's very natural. Okay na? In the case of filtration also same thing happens. From high concentration to low concentration it will move. Okay, now we will see passive diffusion. Actually passive diffusion is very easy, and what it is called, it is very natural. Okay, so there is no uptake or requirement of energy is needed in the case of passive diffusion. See, the drug diffuses across the membrane in the direction of its concentration gradient. That means, what does concentration gradient means? Concentration gradient means there is a difference of concentration. In one case there are more concentration, in the other case there are very less concentration. So if there is a difference between two different concentration, one is having high concentration, one is having low concentration, that condition is called concentration gradient. So movement of any substances from high concentration to low concentration without the expenditure of energy or without energy expenditure is called passive diffusion. So the membrane playing no active role, in the process. This is most important mechanism for majority of the drugs. So drugs are foreign substances, they are called xenobiotics. Drugs are foreign substances, and specialized mechanisms are developed by the body primarily for normal metabolites. Okay, lipid soluble drugs diffuse by dissolving in the lipoidal matrix of the membrane. So if a membrane having lipid layer, then lipid soluble substance will go, or they will transport from one side to the other side very easily because they are lipid soluble. So transport of or diffusion of the substances across the membrane will be very easy, and it is rapid. Okay, so the rate of transport being proportional to the lipid. So what are partition coefficient of the drug? Okay, so in that case the rate of transport being proportional to the lipid is to water concentration. That means 1:1 or 1:0.5, like this. In the case of lipid soluble, if the membrane is also lipid, so the what is called proportion will be 1:1. That means the flow will be passive, and it is very easier without expenditure of energy. It is very rapid. Okay, a more lipid soluble drug attains higher concentration in the membrane and diffuses quickly. That's what I am telling from last 5 minutes. A more lipid soluble drug attains higher concentration in the membrane and diffuses quickly. Also, greater the difference in concentration of the drug on two sides of the membrane, faster its diffusion. So ultimately diffusion, there are two important parameters which plays important role in diffusion. So what are they? Number one, solubility. Number one is solubility and number two is concentration gradient. So number one is solubility, and number two is concentration gradient. So when there is more concentration, so when there is more concentration gradient, the diffusion will be more. When there is more solubility, the diffusion will also be ultimately more. Diffusion will be more in two cases. Number one, if solubility is more. Number two, if concentration gradient is more. Okay, now we'll see another important point, that is, if the membrane is made up of polar substances, and that is called water soluble, or the substance, if you are taking any drug or any substance that is water soluble, then in that case what will happen, it will not diffuse through the lipid membrane easily, but it will definitely diffuse through the polar membrane easily, that is water membranes. Okay. Next, influence of pH. The most drug are weak electrolytes. The influence of pH is very, very important. You have to understand that. Why? Because whenever you will study the clinical toxicology, or whenever you will do the clinical study, in that case you will see almost all of the drugs are weakly ionized. They are weakly ionized, or either they will be weak acid or they will be weak base. There is a very important reason behind that. So we will know this today, and that's why pH is very, very important. Most of the drug are either weakly acidic or weakly basic. You will never see a strongly acidic or strongly basic drug. Okay na? So what are the influence of pH? Most drugs are weak electrolytes. See, most drugs are weak electrolytes. Their ionization pH depends on the contrast strong electrolytes that are nearly or completely ionized at acidic site as well as alkaline pH. Simply if I'll tell you, then you have to remember, when a drug is strongly ionized, then it will either be strong acid or it will be strongly ionized. Then it will either be strong acid, or it will be strong base. So you have to remember one thing, strong acid and strong base are ionized completely. Strong acid and strong base are ionized completely, whereas weakly acidic substance or weak acid or weak base ionizes doesn't ionizes completely. They ionize partially. So partial ionization will lead to the production of conjugate acid or conjugate base. That's why what will happen, the partial ionization is very important in the case of drugs absorption in the body after the administration of drug inside the body. Okay na? So that's why you will not see any strongly ionized drug, whether it will not be strong acid or it will not be strongly basic. In contrary, you will see weakly ionized drug almost maximum. The reason behind that is very easily, I told you now. Strongly acidic drug ionizes completely and they becomes conjugate base. If it is strong acid, then it will become conjugate base. If it is strong acid, then it will become conjugate base. And if it is strong base, it will become conjugate acid. That's why they always in equilibrium, and they keeps they keeps transferring from one form to another. That's why you will never see a strong acidic drug or strongly basic drug. Okay. Number two, second thing is that if they are weakly ionized, then bioavailability will be more. And when bioavailability will be more in the body, ultimately pharmacological action or therapeutic action of the drug will be seen very effectively. Okay. Now see, in that case, whatever I told, passive diffusion. So see, I'll tell you, explain you very easily. This is the chamber where concentration of two types of drug are more. One is water soluble, another one is lipid soluble. Okay na? Now this is the membrane. This is the membrane. If this membrane is lipid soluble, then what will happen? All the red dots which are lipid soluble drugs, they will pass through the lipid soluble membrane very easily. Yes or no? Yes. But all the square shaped drugs, blue color square shaped drugs, they are no, they are water soluble drugs. Okay, or they are called non-lipid soluble drugs. So when non-lipid soluble drugs are there in high concentration, they will not transport across the lipid soluble membrane. If you see properly, all the square shaped drugs are not transporting from high concentration to low concentration in this area. This is not area, this is the membrane, this is the lipid soluble membrane. All the red dots, that is lipid soluble drug, are passing through this membrane. Why? Because they are lipid soluble and the membrane is also made up of lipid. But all the non-lipid soluble drugs, that means all the ionized drugs, are not passing or transporting through this lipid soluble membrane. Rather, they are transporting through the channel, and this channel is called water pore, or you can also say this is aquapore. This is aquapore. Through this aquapore, this water soluble membrane or non-lipid soluble membrane are going, that is square shaped. All the square shaped drugs are transporting from high concentration to low concentration. Ultimately, diffusion is the movement or transport of substances from high concentration to low concentration through a semi-permeable membrane. Now you understood this drag or not, this diagram or not? See illustration of passive diffusion and filtration across the lipoidal biological membrane with aqueous pores. I hope you understood it very well. Okay, now we will see the ionization of a weak acid. See the ionization of a weak acid. HA is given by the equation pH equals to pKa plus log ionized form upon non-ionized form. So pK is the negative logarithm of the acidic deconcentration electrolyte, weak electrolyte. All these things you don't need to understand, you don't need to memorize, but you need to understand. Ultimately, you have to understand this thing, ionized form. So when ionized form and non-ionized form are equal, in that case the ratio will be 1, and when the ratio will be 1, in that case the transport or absorption will be more, or you can say maximum. Since log 1 is 0, under this condition pH equals to pKa. That means if you take the condition of, or what it is called, pH of drug as pKa, and if you consider the pH of site of administration as pH, see this is the stomach, this is stomach, yes or no? In the stomach, what will be the pH? pH is 1.6, yes or no? The pH of stomach is 1.6. And again, if the pKa of this drug, is also very less, like 1.678 or 2, that means what will happen? Absorption will be very much less. Okay, when these two having pKa and pH ratio are equal, in that case this is the pH of the drug, but after the ionization it will convert into pKb. What is that pKb? pKb is the concentration of the ionized drug after the ionization. Okay, so in that case what will happen? If you have a weakly acidic or weakly basic drug, in that case that ratio will be 1. One second, please, one second, I am having a very important call. Please wait. So, sorry, actually, I got an urgent emergency call. Not emergency, important call. Okay, let's continue again. So thus, when the pK is numerically equal to pK is numerically equal to pH at which the drug is 50% ionized. If the pH increased by 1, then what will happen? Ultimately, if there is a high difference, or if there is a ratio which is far away from 1, in that case the absorption will be very less. Absorption will be maximum, or absorption will attain peak level when the ratio of pH and pKa value will be 1. Okay, so thus weakly acidic drugs which form salt which contains such as sodium phenobarbital, sodium sulfadiazine, and penicillin V, these all are the drugs which will be absorbed more, ionized at alkaline pH, and 1 scale range in pH causes tenfold change in the ionization. Ultimately, the most important point will start from here. So, weakly basic drug which form salt with anions, example atropine sulfate, ephedrine hydrochloride, and chloroquine phosphate, etc., conversely ionize more at acidic pH. So, when they will ionize more at acidic pH, ions being lipid insoluble do not infuse, and a pH difference across a membrane can cause the differential distribution of the weakly acidic and weakly basic drugs on two sides. So when C, if ionized drug will be there, so ionized drug will be absorbed more. If ionized drug will be there, ionized drug will be absorbed less. Okay, so you have to understand that. See, in that case pH is 5, in that case pH is 7. So in the case of pH 7, more will be absorbed. In the case of pH 5, less will be absorbed. So the important influence of so implication of this consideration are acidic drugs such as aspirin are largely ionized at acidic gastric pH and are absorbed from the stomach, while bases, example atropine, having pKa 10, are largely ionized and are absorbed only when they reach the intestine. So, if a drug having pKa value more, they will be absorbed in intestine in alkaline medium, and if a drug is acidic in nature, they will be absorbed in acidic medium. So the acidic medium in GIT is stomach, and the alkaline medium in GIT is intestine. So atropine is an alkaline drug, and it will be largely ionized and are absorbed well only when they reach in intestine. Okay na? So simply they will ask the question such as aspirin will be absorbed more. Aspirin will be absorbed more in number one option stomach, number two intestine, number three intestine, or they will say uh, ileum, jejunum or ileum they will mention, because that will be more specific. So the answer will be aspirin will be absorbed more in stomach. Why? Because aspirin is acidic in nature, they are having acidic pK, and they are largely ionized in the gastric acid pH and are absorbed more in stomach. Okay now. Ultimately, acidic drug will be absorbed in acidic medium. Basic drug will be absorbed in basic medium. Okay, sorry. Basic drug will be absorbed in basic medium. So what is the acidic medium? Acidic medium is stomach. What is the basic medium? Basic medium is intestine. Now, in that case, again you have to understand, if it is strongly acidic, that it will not be absorbed. If it is strongly based, then also it will not be absorbed. But if it is weakly acidic, it will be absorbed more. And if it is weakly basic, then also it will be absorbed more. Okay. Number 2 point is that the unionized form of acetic drug which crosses the surface membrane of the gastric mucosal cell reverts to the ionized form within the cell at pH 7 and then only slowly passes to the extracellular fluid. This is called ion trapping, a weak electrolyte causing a membrane to encounter a pH from which it is not able to escape easily. These may contribute to the gastric mucosal cell damage and caused by aspirin. So ultimately, what is the side effect of aspirin? A side effect of aspirin is cell damage or mucosal cell damage. Ultimately, they will lead to the gastric acid, what it is called, ulcer, gastric ulcer. They will lead to gastric ulcer. Okay. Next, basic drug. Basic drug attain higher concentration intracellularly at pH 7 and pH 7.4 of plasma. Acidic drugs are ionized more in alkaline urine, do not back diffuse in the kidney tubules, and are excreted faster. According to basic drugs, Accordingly, basic drugs are excreted faster in urine as acidified. Okay. See, lipid soluble non-electrolytes such as ethanol and diethyl ether readily cross the biological membrane, and their transport is pH independent. So ethanol and diethyl ether are pH independent. Can you tell me three barriers present in human body? Okay, the most common barrier is blood brain barrier, if you remember BBB. Then blood brain barrier is the first and foremost and most important barrier. Number 2 is placental barrier. Number 2 is placental barrier. PB. Placental barrier is present in the case of pregnant mother and the infant. There is not infant, that is zygote. Okay. Now filtration is passage of drugs through the aqueous pores in the membrane through paracellular spaces. Okay, this can be accelerated if hydrodynamic flow of the solvent is occurring under the hydrostatic or osmotic pressure gradient. So when there will be more water in one part and less water in another part, what will happen? More water will go or transport from high water to low water area. That is highly osmotic to across the membrane, or it is also called across the osmotic pressure gradient. So from high concentration to low concentration, it will be transported. Okay. Example, across most capillaries including glomeruli, lipid insoluble drugs cross biological membranes by filtration if their molecular size is smaller than the diameter of the pores. What are that pores? They are the aquapores. Okay. So lipid insoluble drugs cross biological membrane by filtration if their molecular size is smaller than the diameter of the pores. Majority of the cell, such as intestinal mucosa and RBC, have very small pores, that is 4 angstrom, and the drug with molecular weight more than 100 or 200 are not able to be penetrate. So however, capillaries, except those in brain, have large paracellular spaces, that is approximately 40 angstrom, and most drug, even albumin, can filter through these. Albumin also can filter through this. Which one? The capillaries. Okay. Such diffusion of drug across the capillaries is dependent on rate of blood flow. These are not dependent on pH, rather they are dependent on rate of blood flow through them, and rather than on the lipid solubility of the drug and pH of the medium. So the drugs such and albumin and some drugs which are having molecular weight more than 100 or up to 200 or more than 200, they are not, their diffusion or their transport is not dependent on the pH of the medium or lipid solubility. Rather, their transport or absorption or transport across the membrane is dependent on the rate of blood flow. It is dependent on the rate of blood flow. Okay. So specialized transport, you will see some specialized transport such as carrier transport. These are also called carrier mediated transport. Okay. And these are done by pinocytosis. Okay, so carrier transport, all cell membrane express a host of transmembrane protein which serves as a carrier or transporters for physiologically important ions such as nutrients, metabolites, transmitters, etc. Across the membrane, at some sites, certain transporter also translocate xenobiotics. Xenobiotics means Xenobiotics means drugs or any foreign particles. See, also previously I told you about xenobiotics here. If you remember. So xenobiotics ultimately these are the um, foreign particles or foreign substances, including drugs. Oh, sorry, it is written here only now. Why I'm searching somewhere else? So xenobiotics including drugs, but I mentioned drugs and their metabolites. In contrast to the channel, which open for a finite time and allow passage of the specific ions, transporters combines transiently with their substrate, ion or organic compounds. Okay, so ion, these substances undergo a conformational change, carrying the substance to the other side of the membrane, where the substrate dissociate and transport returns back to the original state. What does it means? These are the channels, protein channels. See, this is a lipid layer. This is another lipid layer. So these are lipid bilayer. In this lipid bilayer, you will see a protein channel like this. Okay. This is the protein channel. Through this protein channel, substance will go inside the cell through this protein channel. So in that, what will happen? There will be a mechanism like this. So when the substance will come and bind here, it will change its shape. Change its shape. That is called. I'll show you once again. And transport returns back. Conformational change. The change of the shape is called conformational change. And due to that conformational change, what will happen? The substance will go from first one to second one. Again, second one will undergo conformational change. It will go to third one. Third one will undergo conformational change. It will go to the fourth one. Fourth one will undergo conformational change, and it will ultimately go to the inside the cell. This is the lipid layer. This is lipid layer. These are lipid layers, and this is the ion channel, or this is the carrier transport. So through the transport, the drug will go inside. Through this transport, the drug will go inside. Okay. So you have to understand, and you have to remember that conformational change carrying the substrate to the other side of the cell or other side of the membrane, from outside the cell to the inside cell, or from inside cell to the outside cell. And again, after transport of the substance from outside the cell to inside the cell, or from one side of the membrane to another side of the membrane, the conformational change will again go back to its original structure, that is called original shape, and the shape will be recovered. So, and they will go back to their return back to their original state. They will return back to the original state. This carrier transport is specific for the substrate. This carrier transport is specific for the substrate or type of substances. Example, organic anions. Saturable, competitively inhibited by analogs which utilize the same transporter and is much slower the flux through the channel. Now this is very important point you have to remember. In that, three terms are there. The first term is saturation. So where is that saturation? Transport, first term is specific. You have to remember that specific word. What is this? This is specific. So this carrier transporter specific to the specific substrate. Anyone cannot pass through this carrier transport. Number 2 is these are saturable. This is also very important. And number 3, these are these can competitively inhibited by using analogs. Okay, so for example, there is a transport channel. Okay, why I am drawing this, the channel is already present here. Now 1 second, I will show that. See, this one is the channel. For example, this one is the channel through which some drugs are going inside or outside the cell. That means they are moving from one side to the another side. They are transported from one side of the membrane to the another side of the membrane. Okay, now for example, this is the cell membrane, this is outside of the cell, this is inside the cell, this is the cell membrane. Okay, now these substances, one substance, for example any drug, it is going from outside membrane to the inside the membrane. This is cytosol. Cytosol means inside the cell area, and this is outside the cell area, extracellular part. Now for example, this drug is going from outside cell to the inside cell through the pore. In that case, if the number of pores are 100, then what will happen? Only 100 drugs can go through this channel. That is called saturation. For example, you are going or you are passing a river. See, there is a river. This is a river. There is a river present here. This is a river. On that river, a bridge is present. On that river, a bridge is present. This is a bridge on the river. This is a bridge on the river, and alongside this, the road is present. Okay, now in one side of the river, if 100 people, 200 people, 300 people, or even 500 people are present, but the capacity of the bridge is only 100, then what will happen? In one time, how many member will pass through this bridge? Only 100 member. Even if 500 people are also present, that all 500 can't pass or can't go from one side to the other side through this bridge. Why? Because the capacity of bridge is only 100. That is called saturation. So if 100 people are also present, they will also go. If 200 people also present, only 100 will go. If 500 people are also present, only 100 will go. That 100 is the capacity of that bridge. In the same way, if these pores are only 100, then what will happen? If you are taking 500 units of drug, or if you are taking 500 concentration of drug, then how much drug will go through, or how much drug will pass through this membrane? Only 100 drug. If the capacity is 100, then this 100 will be the saturation for this passage. Yes or no? So this is called the saturation, or that's why this is called saturable. Number 2 is specific. That means where is that bridge? Yes, if a condition is written on the board that only female can pass through the bridge, only female can pass through this bridge, no male is allowed to pass through this bridge, then what will happen? Out of that 100 people, if 50 are female and 50 are male, then how many people will pass? Only 50 people will pass. How many people? Only 50 people will pass. Why? Because it is specific. Number 2, out of 500 people, if 100 are female or 50 are female, earlier one condition I said, that is only 100 will be allowed, that is saturation. Now another condition, in that condition, out of 100 people, if 50 are female, then now 100 will not go, only 50 people will go. Why? Because only females are allowed. Out of 500 people, if 50 are women, then also only 50 people will pass through this bridge. That is called specific. So this bridge is specific to female. In the same way, that channel will also be specific to the specific drug. For example, this channel is specific to any ionic drugs or water soluble drugs or non-ionic or non lipid soluble drugs. Then what will happen? Only the ionic substances or only the ionic drug will pass through this pore. That's why it is called specific. That's why it is called specific. It is called specific. Okay, it is called specific. Again, competitively it can be inhibited by using analogs. How? If you take a if you take a truck or bus or anything, or if you take a large wall or something you are taking and you are putting there in front of that bridge, then now if 100 people are present, 50 people are present, or 500 people, or any number, out of that it was specific for women only, right? So if 50 women are present, or 100 women, or even 500 women are also present, but if it if the bridge is blocked, then how many member will pass through the bridge? No one. No one can pass. Why? Because the bridge is blocked now, so no one can pass through the membrane. Yes or no? So for example, if you remember alpha blocker, beta blocker, and like this, nicotinic receptor blocker, ARB. What is ARB? So if you take any type of blockers, then also what will happen? It will block the channel. It will fit on the front side or open side of the channel, and it will block the channel. Now if 50 unit of drug, 500 unit of drug, whether it is specific to non-ionic, then out of 500 only 100 are ionic, 400 are non-ionic drugs are present outside the cell membrane. Still no chance of going or passing or transport of a single unit of drug across the membrane. So ultimately what is happening? The activity of the channel is now inhibited, or activity of the channel is now blocked by using any type of analog. So that's why you have to remember that channels are specific, number 2 that channel are saturable, number 3 that channel are competitively inhibited. That channel are competitively inhibited by analogs that utilize the same transport. Okay, and it is much slower. Why it is much slower? This is also very important. You need to understand why it is much slower. Why it is much slower? Because in the case of non-ionic substances, what will happen? The non-ionic substances will pass through the membrane anywhere. Why? Because the whole cell membrane will be made up of lipid bilayer, and lipid will so non-ionic substances will pass through the lipid layer. So thousands of unit of drug will be transported from one side of the substance or one side of the membrane to other side of the membrane. Whereas, one second. Whereas, if some pores are present allow the passage of which only allow the passage of ionic substances, and the pores are limited in number, then what will happen? The transport of that ionic substances will be less or more? It will be less. Why? Because when only 3 ionic substances will be transported from one side of the medium to another side of the medium, thousands of red color non-ionic substances will be moving. Yes or no? That's why the pore channel or spatial channel transport is slower compared to the passive diffusion or compared to the other transport medium. So carrier transport is specific, number 1. Number 2, carrier transport is saturable. Number 3, carrier transport activity can be inhibited by using competitive analog. And number 4, carrier transport are usually slower than the flux through the channels. Okay, Now we will see the diagram, image, in that we will understand it very well. See, this is the diagram. Number 1 is from low concentration, this is the membrane, and then high concentration on the right side. So these are poorly diffusible substances or substrate. Now what will happen? They will go and bound to the channel membrane, what it is called, solute carrier transporter. So ultimately carrier transporter. So they will go and bind to the carrier transporter, and again carrier transporter will release on the other side, and it will go back to its original position. After release of substances from one side to the other side, the carrier transporter will be reactivated, and it will undergo conformational change, and it will go to its original position. Okay. And here, if you see that there are two substrate, one is substrate A, another one is substrate B, then that carrier channel is specific. That carrier channel is specific. In that case, what will happen? This round or circular shape substrate will go from one side to other side, and the transport of that circular shaped substances are only allowed. That is specific. That is specific. And in that case, saturation. In that case, saturation. So see, facilitated diffusion. The carrier solute carrier transporter bind and moves poorly diffusible substance along the concentration gradient from high concentration to low concentration, and doesn't require any energy. So facilitated diffusion, you have to remember, facilitated diffusion doesn't require any kind of energy, and it will bind the substance, and it will transport the substance from high concentration to low concentration. In B, in the case of B, you will see primary active transport. In primary active transport, carrier such as A, B, C, this is the carrier, and it derives energy directly by hydrolyzing the ATP. So ultimately energy is required and moves the substances against the concentration gradient. So earlier what was happening? The substances were moving from high concentration to low concentration. But in case of B, the substances are moving from low concentration to high concentration. See, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 substances only, and here almost 25 to 30 substances are present. But still, substances are moving opposite to the concentration gradient. Opposite to the concentration gradient means from low concentration to high concentration. So, for example, if you are taking water, this is a mountain, and if you are taking water from the down part of the mountain to the upward of the mountain, then what will happen? Energy is required or not? Yes, definitely energy is required. But if you are taking some water from upside of the mountain to the downside, such as hill, in that you will see some, what it is called, waterfall. In the case of waterfall, you will see it is happening spontaneously without the expenditure of any energy, and passively it will happen. So very easily the water will come down from high concentration to low concentration, or high area, high altitude to low altitude. But when you are taking some water from low altitude to high altitude, it will definitely require energy. In the same way, diffusion and osmosis are also spontaneous process and passive process. That's why there doesn't require any type of energy. In that case, from high concentration to low concentration, the substances will move passively and spontaneously without the expenditure of energy. But in the case of active transport, the substances will go from low concentration to high concentration with the expenditure of energy, or by uptaking the energy from the ATP. These energy are released by hydrolysis of ATP. Okay. In the case of C, you will see symport. If you remember earlier, I mentioned in the case of aquaporins, I mentioned mm, three different types of transport. They are symport, symport, uniport, and antiport. So in the case of symport, both the substances will go in same direction, and in the case of antiport, both the substances will go or move or transport in the opposite direction of the membrane or concentration gradient. Okay, so in the case of C, you will see substances are moving only in one direction. Substrate A is also moving from low concentration to high concentration, and substance B is moving from substrate A is moving from low concentration to high concentration, and substrate B is moving from high concentration to low concentration. If you take substrate B as red points, then red points are moving from high concentration to low concentration, whereas substrate A, that is prism shape, the triangular shape, they are moving from low concentration to high concentration. Ultimately, the concentration gradient are opposite. Transport of substances are also in opposite gradient. That is, one is from low concentration to high concentration, one is from high concentration to low concentration, but the direction of transport are same. So transport of different substances in same direction is called symport, and the transport of different substances in opposite direction is called antiport. In the case of D, you will see small triangular substances, that is substrate A, from low concentration to high concentration, they are moving from left to right, whereas substrate B, that is red points, they are moving from high concentration to low concentration. Earlier also they are going from high concentration to low concentration, but in same direction. See, this is the direction, this is the direction, they are moving in same direction, but now in that case they are moving in opposite direction. Both the different substances are moving in opposite direction. That's why D is called antiport, C is called symport. Now you see, if you read that symport, the carrier moves substrate A against the concentration gradient by utilizing energy from downhill to uphill movement of another substance B in the same direction. Whereas in the case of antiport, both the substances are moving in opposite direction. So carrier moves the substrate A against the concentration gradient is energized by downhill movement of the another substrate B in opposite direction. So in symport you will see same direction, but in antiport you will see opposite direction. Okay, so this all about transport of substances. Okay, now we will see facilitated diffusion. So the transporter belonging to the superfamily of solute carrier, superfamily solute carrier or transporter operates passively without needing of energy. Operate passively without needing of energy, and translocated the substance in the direction of its electrochemical gradient, that is from higher concentration to lower concentration. It merely facilitates the permeation of a poorly diffusible substrate, example entry of glucose into the molecule and fat cells by the glucose transporter, that is GLUT4. Number 2, that is active transport. Active transport means transport of substances from low concentration to high concentration with the usage or expenditure of energy. So in the active transport, it requires energy. First point, it requires energy. Is inhibited by metabolic poisons and transport the solute against the electrochemical gradient, that is from low to high, resulting in the selective accumulation of the substance on the site of membrane. Drugs related to normal metabolites can utilize the transport process meant for these. Example levodopa and methyl dopa are actively absorbed from the gut by aromatic amino acid transporter. So levodopa and methyl dopa are actively transported or absorbed from the gut by using aromatic amino acid transporter. Okay. In addition, the body has developed some relatively non-selective transport like P-glycoprotein (PGP) to deal with the xenobiotics. Xenobiotics means drugs or foreign substances. So active transport can be primary or secondary depending on the surface or source of the driving force. Primary active transport. Energy is obtained directly by hydrolysis of the ATP. Primary active transport means in that active transport means obviously uptake of energy will be there. So that energy is obtained directly by hydrolysis of ATP. But the transporters belongs to the superfamily of the ATP binding cassette. ABC ATP binding cassette transporters whose intracellular loop have ATPase activity. So this ATPase is an enzyme activity. That ATPase activity will be the enzyme activity. Okay. They mediate only efflux of the solute from the cytoplasm either to extracellular fluid or into an intracellular organelle. Okay, such as endoplasmic reticulum and mitochondria. In the case of endoplasmic reticulum and mitochondria, etc. Okay, next, encoded by multi-drug resistance. So, sorry for the inconvenience. Let's start again. Encoded by the multi-drug resistance MDR1 gene PGP. PGP means what is PGP? Now I told you PGP. PGP is P glycoprotein. PGP is P glycoprotein. Okay. One second, please. Okay, we'll see later. I don't know what is happening. Some people are telling that it is not being in the large screen. That is horizontal vertical. So I think the screen is not in the horizontal condition. It is in vertical condition. I have to stop the live here and we will start again in the next live. Okay. Thank you for being connected with me. Thank you. If you like if you understood the lecture properly, then please do like and share.